Let's talk about parallelograms. As you might have guessed from the name, a parallelogram is named that because it has two pairs of parallel sides. So in this picture, the top and bottom sides are parallel, and the left and right sides are parallel. Now, we also, in a parallelogram, those pairs of opposite sides are also congruent. So I'm going to mark those sides to be congruent, just like that. Now, because of the fact that those lines are parallel, I'm going to extend these lines a little bit, just so you can see that over here on the left side, we have some parallel lines here, and you may recognize some things from your previous geometry studies. What we have here is a set of same side interior angles. So right there, that green angle there, and this red angle down here. And because they are same side interior angles, we will say that those two angles are supplementary to each other, meaning they add up to 180 degrees. We can also do the same thing on this side. And since, we have same side interior angles on the top as well, that green angle and red angle are also supplementary, adding up to 180 degrees. So then you can see that the opposite angles, the angles on opposite corners that I have marked in red, must be congruent, because if you have two things that add up to 180 and then one of those plus an additional thing for make 180, then those two red ones have to be the same, and then we'll mark this green angle down here as well. So we have those happening with the angles. Opposite angles are congruent, and consecutive angles, angles that are next door to each other, are going to be supplementary. They will add to 180 degrees. Now you also see the diagonals connecting opposite corners, opposite angles, those lines that go through the shape. And those, they're not the same length, because it's a leaning shape. You can see it's kind of leaning to the right. So the distance from bottom left to top right is longer in this shape than the one from top left to bottom right. But what we can determine is that, let me use a darker color there, but these lines are the same length, and these are the same length. So we would say that these diagonals bisect each other. They cut each other in half. And of course, we have some vertical angles here in the middle that are equal, that are congruent. We also have alternate interior angles. This is a big deal as well, where this angle here that I'm marking in yellow is alternate interior along this line with this part here. And then that's also going to happen on the other side as well. So this half is going to be the same as this one, and then we're going to have a similar thing happening on the other side, alternate interiors there and there, and we'll go there. I'm kind of running out of colors here, but you're going to get the idea. So because of alternate interior angles that happen because of these parallel lines, these parallel sides that we have all kinds of alternate interior angles happening as well. So you can see we've got a very complex shape here, this parallelogram. And what I'm going to do here in the next few slides is show you some examples of problems that you may see in your geometry class or on your standardized test or what have you, that relate to these very unique traits of the parallelogram. So first off, let's talk about these diagonals here. We've got a couple of the parts of these diagonals marked. We have UO that is marked as 15 units long, and OT, which is marked as 9 units long. And you can see that we are being asked to find OS. S is that one up in the corner. I think we missed labeling S. Let's label side S up there. So, oops, excuse me. Excuse me again. There we go. Still getting used to the technology. There we go. So there's S there. And so we're being asked to find OS. Well, we know in parallelograms that diagonals are bisected. So you can see OU here is 15. That means OS is also going to be 15. Now we're also asked to find RT. So now that is the entire length going from top left to bottom right. And we have part of it here with 9. Now again, since diagonals bisect each other, those two halves of line RT are going to be the same. So this side is going to be 9 as well. But we want the full length of RT. So we would just get that by doing 9 plus 9, which is, of course, 18. So that's pretty easy when we deal with just constant numbers, but occasionally you will see some problems involving diagonals or sides or angles of these shapes that involve algebra. So here you can see we are being asked to find the length of JL, and along JL here you can see we have a half of it that is labeled 6y minus 3 and another half that's labeled 2y plus 9. Well, if we go back to our facts that we know about parallelograms, we know that the diagonals are bisected, so that means that those two halves are the same size. So let's set 6y minus 3 equal to 2y plus 9. Now we're going to do a little bit of algebra. We're going to subtract 2y from both sides, and we'll get 4y equals, and then we will add 3 to both sides and get 12. 4y equals 12. That means y is going to equal 3. Now, we're not asked for y. We are asked for the length of JL. That's the entire diagonal. Well, if we plug in 3 in for our variables, we're going to get 6 times 3 minus 3, which is going to be 15. Because the two halves are equal, we expect that we're going to get the same value on each side. 6 plus 9 is also 15. And then 15 plus 15 will give us a length of 30 for the full length of that diagonal. Now let's move on to some problems about sides. We remember that opposite sides of a parallelogram are equal. So in a problem like this isn't too hard. 10 and y are opposite sides. They should be equal. So this side is going to be a length of 10, and this side will be a length of 15 because it is opposite a side marked 15. Again, not too terribly difficult. We actually didn't have to do any computation there. But if you throw in some algebra, we're going to have to set up an equation. So opposite sides, again, they're equal. So let's set them equal to each other. 10y plus 15 equals 5y plus 30. We will subtract 15 from both sides, and we will subtract 5y from both sides. and that's going to give us 5y equals 15, y equals 3, and that is y. Now, if we were asked to plug that 3 in and actually get the length of these sides here, 10 times 3 is 30, plus 15 is 45, and then we would expect this side to also be 45. And if we do the math on it, it turns out to be. So, again, opposite sides in a parallelogram are congruent. What we don't have is any way to make a necessary relationship between one set of congruent sides and the other set of congruent sides. There is no set relationship between those two things. And then finally, let's look at some problems that involve angles. So here we have two consecutive angles in a parallelogram. One is marked x and one is marked x plus 40. We know that these guys are supplementary. We know they're not going to be congruent. That's usually our other choice when we're dealing with angle problems and setting up equations, because one of these is acute and the other is obtuse. And in a parallelogram, that's always going to be the case. And so we would also expect the obtuse one to obviously be larger than the acute and over 90 degrees. We would expect the acute one to be less than 90 degrees. So let's set up this problem here. One angle is x, the other one is x plus 40, and they should add up to 180. Now, you see those two x's, we can combine like terms there to get a new equation like this. 2x is going to be 140, x is going to equal 70. So this is a 70-degree angle. 70 plus 40 is 110 degrees up there, and notice that they add up to 180 just like they should. We also know that opposite angles are equal, are congruent. So we're going to put 70 degrees up there and 110 down there, and we've solved for all the angles of this parallelogram. Now, here's a fun thing we can do here. We can actually solve for every missing angle in this shape, just given this information. So I'm going to talk you through this exercise, and you can see how this is done. Well, first off, we have some alternate interior angles happening here. So this 38 is going to be alternate interior with that one up there. They are on opposite sides of the diagonal and inside the parallel sides, which means they're interior to the shape. So that's going to be 38. We can do the same thing with the 25. It is going to be up there because of this 25 down here. We can also do the same thing with the 104. It is alternate. It is on the other side of the diagonal as well in the opposite corner. Now, we have some other angles that we need to know. One thing we can do is recognize that this angle is going to add up to 129. We would know because consecutive angles are supplementary, that this big angle up in the upper right is going to add up. It's going to be the supplement of 129. So we can do this quick equation, which winds up being 51, to be this entire angle up there. And then 51 minus 38 will give us that missing part up there, and that's going to be 13. So this is 13. And because of, again, alternate interior angles and the fact that opposite angles are equal, this is going to be 13, so this will be a sum of 51. This up here will also be a sum of 129. Now, we're not quite done because we have all of these angles around the center to deal with. And this is where we can use the fact that 3 angles in a triangle add up to 180 degrees as well. So if we look, for example, at this triangle here, we can see that we have used up out of the total, oh, that thickened up on me. There we go. 180 minus 38 minus 25 is going to give us this angle right there. So that is going to become 117 degrees. 117. And because of the power of vertical angles, 117 there. And then we have linear pairs. This is going to be a linear pair, so it's going to add up to 180 as well. So 180 minus 117 is going to give us 63 degrees for each of these. So that's the type of thinking that can help you find any angle, any missing angle in a parallelogram. I hope you found this video helpful. I am building my collection of math instructional videos. It'll be geometry. I envision having some algebra in there, maybe some statistics, maybe some other things. So if you have a request, feel free to drop it in the comments, and I'll put it on the list to get produced. Thank you very much for watching. Good luck to you. You're doing a great job. Take care.